Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge and its question name is let me show the question only. So here's the question. Let me zoom it out so that it is much more clearly visible. And whatever question it is, we'll be doing both of the approaches. Yeah. Okay. So today's question name is add one row to tree. So basically in this question we are required to add up one row at a particular level and the values of that particular nodes which we will be adding, that also is given to us. So that is thing, and in that the thing is that we are required to think that how we can add those particular at a particular level. So now let us first read the question, then check about the constraints so that we can get to know that what would be the time complexity and the space complexity, and then we will be going ahead that how we are required to process question. So given the root of a binary tree and two integers val and depth, add a row of nodes with value val at a given depth. Okay. And note that the root node is at the depth 1. So basically our tree starting from the depth 1 means whatever root node is having the depth that is at 1, not at 0. So that they want to convey us. And the adding rule is basically at what level we are required to add and what is the criteria to add a particular node. So we are required to take these 4 points for the tree. So given the integer depth, for each not null tree node current at the depth minus 1. So basically, when our tree is basically not null, means it is having some root, node means means it is having some depth, means some node is there at the depth 1. Then in that criteria, we are required to create two tree nodes with value val. Val is also given to us as current left subtree root and right subtree root. So basically, whatever we are node which is being given to us, right? So basically, we are required to check that is that node at that particular depth at which we are required to add our value or not. If it is not at depth, then we are required to go ahead in more depth and then check that are we able to reach at that particular depth or not. So here the thing is, in that manner only we will be going ahead in that tree, and then when we figure out that this is the required depth, then we will be adding at that level are those nodes whose value is being given in the val variable. So that is the thing. And whatever was there at that particular means at that particular let me draw and explain that would be much better. So if we are at this particular, this is a tree given to us. Okay. So our depth is being given to us as this is at 1 and this is at 2, right? So our depth is being given to us that we are required to add a nodes at 2 depth, right? So what we will be going to do is that we will be adding at these levels, right? So that we are able to add our nodes at 2 levels, right? And the value which is being given to us is 3. So the new tree would be something like this, 3, 3, and whatever was at left and whatever was at right, it will be at left only and it will be at right only. So this is the new required tree, and this is the criteria which is being given to us. That val is being given to us already, depth is also given to us already, and we are only required to add at that particular depth that value which is being given to the question that we will be adding, right? And after adding that, whatever was there earlier, means this 2 and 3 which was there earlier, that we will be adding to the next level of these newly added nodes. And the new, these previous ones which are being there, these when we are adding to the new level, then at that particular time, those should be at that side only. Means basically if they were at left side, right? So to the newly added nodes, these will be again to the left side only. and this will be to the right side only. That's the thing they want to say. And even they are to the left side, still they should be towards left only, not towards the right. Means this would be wrong, but this is correct. And same goes for this part also. So this is the thing which we need to take care. So basically these are the adding on criteria. And one more thing which they have given to us, if the depth to at which we are required to add is 1 and the value, whatever value, may say x, any value is given to us, and the tree which is being given to us, whatever that tree is. So at this particular moment, what we will be doing is we will be directly adding like this, and whatever tree was there, we will be adding that at, but that would be added to the leftmost, not to the rightmost. So this is the thing which we will be, means whatever tree is being there, that we will be adding towards the left. If our depth is equals to 1. So this is what they are saying, that if depth equals to 1, that means there is no depth minus 1, right? That's for sure. Then create a tree node with value val as new root of the whole original tree, and the original tree is the new root's left subtree. So this is the thing which we are required to do. So in the first case, which I had explained, that was that tree exists, right? And we are required to add our nodes at any particular depth. And the second criteria, which I have explained you, that if we are required to add this particular at the depth 1, then we will be adding that. And whatever tree was there, that tree we will be adding towards the left of this particular tree. So this is a thing which we will be doing here. And now comes the part that how exactly we are going to do this particular question. So, but I think I guess I hadn't created an explanation. Hmm, the only this explanation which I had created, but no issues. I'll create one. So, 1 minute. Let me pause and check something. So while doing dry run, we will be checking that how we are required to do this question. So basically this question could be done by BFS and DFS both, and in both of them time complexity and space complexity would be same. So now let us see that how we are required to do this question. So when depth equals to 2, right? So this is at depth 1. Then what we will be going to do is we will be simply checking that when it reaches depth equals to the depth we are required, at that moment, what we will be going to do is we will be directly, if this, because depth equals 2, so at depth minus 1, that is at this level, whatever node is being present there, right? So we will be directly towards its left adding up a new node with whose value is basically the 1, and then whatever was earlier left of this particular, that is this node, that we will be making as the left of this particular node. Means now this will become, this 2 will become left of a newly added node. And then we will be going ahead further next and so on, and then returning, when we return back at this particular point, then we will be doing same for a right subtree as well, adding up a node here. Then whatever was previous right, that we will be adding to this particular, that's the thing which we will be doing, and then moving ahead. And then our whole complete tree would be something like this. So basically the points to consider are that at depth minus 1, whatever current node would be there, right? So towards it left, we will be adding up new node whose value would be equals to val. And when we get back to our parent, means basically to our current node, then towards its right, we will be adding up the new node whose value would be equals to val, and whatever was there as the left subtree, that will be added to this particular new node, And same goes for this particular. So this is how we will be doing in both of our approaches. But the thing is, when it is about BFS, so in that criteria, we will be pushing the left subtree in the queue when we are not at the particular depth which is being required. But when we reach a depth -1, then that particular moment we will be starting forming our tree in such a manner. Means from that queue only we will be getting our depth -1 node, and then in towards the left of that particular we will be adding our new node, and then pushing that to the queue so that when next time it comes up, then we will be adding up a left subtree to the same. And same goes for the right node as well when it is a BFS. But when it is DFS, then in that criteria we will be first going towards the depth of a left subtree, right? So when we go towards the depth of a left subtree, then in that criteria, when we reach a depth -1, then that node would be our current node in which we will be adding up a new node, right? And then after that, we will be moving ahead with that new node, and whatever left subtree was there, that we will be attaching to our present new node. So this is the thing which we are required to do in this question. I don't know what is happening with my internet today. So these are the things which we will be doing. So let me show you that how we are required to do this question by coding part basically. Yeah, whatever internet issues there, let it be. Because my explanation was done. Now I can show you the coding part. So here's the coding part for the same. So this, uh, so this is the first solution for our BFS approach. Although in BFS the only thing is that as we are going level by level, right? So because of going level by level, when we reach our particular value, then in that level, we are easily able to exit from our answer. So that's the only thing which we are saving in our BFS approach. So now here the first thing is, hmm, hmm, okay. So now let us start with our solution, that how we are required to do this solution. So first thing is, this is that criteria when we are having our tree set, but the depth is basically at 1. So at that moment, our depth -1 won't be there, right? So at that moment, we are creating a new node, right? And the value we are adding that value which is being given to us as input. And then towards the left of that new node, we are adding this root. That is the thing which we are doing. And then we are returning the new node, because now a new node is basically the new root of our tree. So this is for handling that particular case. Now here comes the part for the other case. When our depth is basically inside at any level of our tree. When depth -1 is basically present. So at that moment we are going to do our code like this. So here first we are taking this queue, and in that queue we are pushing is doing that BFS as usual which we used to do. Then here our count is equal to 0. This is basically for getting that at what level we have reached. Now, doing our BFS, taking our queue size so that we are able to process till means at a particular level, we are able to process all the nodes. So for that purpose, we are taking the queue size. We are increasing the count for checking that now we are at first level, right? So that's we are increasing the count. And then here for processing of the front node, and then if our count is not equals to depth -1, right? Means presently we hadn't reached at that depth, so in that criteria, we will be pushing to our queue both of the left and right. Else, if we reach the depth -1, then we are required to form our new tree, right? So here we are doing those steps only. Means first we are creating a new node, and then towards the left of that new node, we are basically equalizing with the current left. Means the thing is that at this moment means here we were having this tree, right? So we were having this tree like this. So at one, basically now our new node which is being there, that is say our value was equals to 3, right? So our new node is having this value, right? So whatever was there earlier with the current left, basically this particular thing. So now we are adding that particular here. And current left equals to new node. And then we are attaching whatever is being there with the current. And then same goes with this particular means right side also. So 3 was there as our new node value. And whatever was there as current's right, that we are adding up here. And then whatever was means now we are fixing with this. So basically this is what we are making at this particular level. So at this tree turned into this because of this piece of code. So this is what we are doing. And when this all is done, then we will be directly, basically now this whole criteria is done, right? So at the end, after the loop ends, then we can return. But the thing is like, I can also put a break at this moment only so that it comes out of the loop. And just for saving my time. Let us check that it works or not. If it works, then we can put a break, and because of putting that break only, it comes out of the tree at from that level itself. Let us check. I guess internet. I need it is time to do. Yeah, it is back now. Hmm, if that break statement is alright, then because of that particular post only, our DFS would be much more faster. Basically. It is there. Let us run this. If we get the correct answer, let us submit it as well. If correct answer is there, then it's alright. Oh, that's not. It is showing out with us. Okay. Sometimes it is missing. So we can't put a break at that moment. So in this criteria, we will be basically directly submitting with this only because earlier this was working. So we can't put break there. Okay. So yeah, when this whole while loop will be completed, then it will be coming out of that loop, and then we will be returning the root. Basically, now we are having that new nodes also in the tree. Now comes the part for our DFS approach. That's how we are required with the DFS. Although DFS is like, it is a smaller version of code. In DFS, we are required with a lot of coding, right? But in DFS, it is much smaller version. So now, let me explain you. Okay. So this is that thing. Basically, this is only acting even as the base case. Earlier, what we were doing was we were doing code for two means. We were doing coding for two different times. Here you can see we were coding for the same thing here also, and we were coding here also. Just because of this fact that depths were basically different, because in one of them it was at the root level and the other one it was in somewhere in middle. But the piece of code and even the thing which we were doing, that was same. Now here that piece of code is basically now only this one, and that has been shortened just because of taking this particular variable and even keeping this particular check. Although this is the only one which is acting as the base case also. So this is like most, not you can say most, but it is optimized version of the code. Although it is DFS, but still. Now, first let me explain you that the major portion of DFS that is going towards the left and going towards the right. Basically, we are having two options. Either we can go towards the left or we can go towards the right. Right? So when we are going towards the left, what we are doing is we are directly passing that to left, V that is whatever a value which we are having, and D minus 1 basically subtracting the depth which is being there. And then when we are going towards the right, then we are also passing this extra variable false. It simply signifies that even if at a particular level we are having our depth, and the thing is that we don't have any left value at that moment, then because of this only we will be able to handle that particular thing. So that's why we are passing the false here, and in this particular left it will be always as true only, because at the starting we are passing with the true. Now when our depth equals to 1, so at that moment basically here we are checking for our left subtree. If left is true, that is it has come from the left subtree only, because when we are required to add our value at the depth one, means basically at the root level, right? So whatever was there as a left subtree, that was required, means whatever was there at the root level, that was required to be added as a left subtree, right? So for that our is left should be true, right? So if it is coming from the left subtree only, right? So it will be marked as true only, right? So that's why is left true, then our left will become as root. That's the thing. Means our left subtree means whatever new node which we will be taking, that will become as root. And whatever, and if that is not the criteria, then it will be null. And same we will be checking for the right. If it is equals to left is true, then we will be adding up null, else we will be adding the root. And then we will be returning with a new tree node where we left and right are being passed to the same. So that is the thing which we will be doing here. And because of this only, we are able to handle both of the cases together when our depth is basically at the root level and when our depth is basically in some means at any particular level. So this is the thing how we are required to do this question. Basically, it is order of basically the time complexity for this particular question is order of n, and the space complexity for the question is both are order of n only. One is because of the recursive stack. Yes, in DFS we are using that recursive stack. That's why their order of n is the space complexity, and the time complexity is, in both of them is order of n only, because see, let me explain you the time complexity and space complexity as well. If a tree becomes a skew tree, right? So here the height of the tree which is being there, that will be equal to n, right? So because of this only time complexity becomes order of n. And same goes reason for the stack as well. That at that time our stack would be having at max n nodes. So that's why space complexity becomes order of n. So yeah, this was all for today's question. If you have any doubt, you could comment that down. And please do like and subscribe to my channel and also do share among your friends. So yeah, this was all. Thank you.